10.7 Moving things around us. Activity 5. Think of some objects you have seen recently. List them in Table 10.4. These may include a school bag, a mosquito, a table, people sitting on chairs, or people moving about. The list may also have a butterfly, a dog, a cow, your hands, a small baby, a fish in water, a house, a factory, a piece of stone, a horse, a ball, a bat, a moving train, a sewing machine, a wall clock, or the hands of a clock. Make your list as large as you can. Which of these are moving? Which are at rest? Here is the table given, Table 10.4, Objects at Rest and in Motion. There are two columns. One is for objects at rest, and the second one is for objects in motion. Items in column 1 are house, table, clock. Items in column 2 are a flying bird, seconds hand of the clock, rest of the table is left blank. Complete this table. How did you decide whether an object is in motion or at rest? You might have noticed that the bird is not at the same place after some time. While the table is at the same place. On this basis, you may have decided whether an object is at rest or in motion. Let us look at the motion of an ant closely. Activity 6. Select a place where you find ants. Spread a large sheet of white paper on the ground and keep a little sugar on it. Ants are likely to be attracted to the sugar, and you will find many ants crawling on the sheet of paper soon. For any one ant, try and make a small mark with a pencil near its position when it has just crawled onto the sheet of paper. Figure 10.11. Keep marking its position after a few seconds as it moves along on the sheet of paper. After some time, shake the paper free of the sugar and the ants. Connect the different points you have marked with arrows to show the direction in which the ant was moving. Figure 10.11 shows motion of an ant. Page 103. Each point you have marked shows where the ant moved to in intervals of a few seconds. Motion seems to be some kind of a change in the position of an object with time. Isn't it? In Activity 5, where did you place objects like a clock, a sewing machine, or an electric fan in your grouping of objects? Are these objects moving from one place to other? No. Do you notice movement in any of their parts? The blades of the fan or the hands of a clock? How are they moving? Is their movement similar to that of an ant or a train? Let us now look at some types of motion to help us understand these differences. (10.8) Types of motion. You may have observed the motion of a vehicle on a straight road, march past of soldiers in a parade, or the falling of a stone. Figure 10.12. What kind of motion is this? Sprinters in a 100-meter race also move along a straight track. Can you think of more such examples from your surroundings? Figure 10.12a and b shows some examples of rectilinear motion. In all these examples, we see that the objects move along a straight line. This type of motion is called rectilinear motion. Activity 7. Take a stone, tie a thread to it and whirl it with your hand. Observe the motion of the stone. We see that the stone moves along a circular path. In this motion, the distance of the stone from your hand remains the same. This type of motion is called circular motion. Figure 10.13 A, B, C shows some objects in circular motion. The motion of a point marked on the blade of an electric fan or the hands of a clock are examples of circular motion as shown in figure 10.13. The electric fan or the clock by themselves are not moving from one place to another. But the blades of the fan rotate and so do the hands of a clock. Page 104. If we mark a point anywhere on the blades of a fan or on the hands of a clock, the distance of this point from the center of the fan or the clock will remain the same as they rotate. In some cases, an object repeats its motion after some time. This type of motion is called periodic motion. Take the stone tied with a string that you used in Activity 7. Now hold the string in your hand and let the stone hang from it. This is a pendulum. Pull the stone to one side with the other hand and let it go. Now the pendulum is in motion. It is an example of periodic motion. A branch of a tree moving to and fro. Motion of a child on a swing. Strings of a guitar or the membrane of drums, tabla, being played. Are all examples of periodic motion where an object or a part of it repeats its motion after a fixed interval of time. Figure 10.14. Figure 10.14 shows examples of periodic motion. Did you observe a sewing machine as a part of Activity 5? You must have observed that it remains at the same location while any point on its wheel moves with a circular motion. It also has a needle that moves up and down continuously. As long as the wheel rotates, isn't it? This needle is undergoing a periodic motion. Have you observed closely the motion of a ball along the ground? Bujo is not sure why we say that the distance of the stone from your hand is the same when we whirl it around. Can you help him understand this? Remember that the stone is held with a string. Page 105. Here, the ball is rolling on the ground. rotating as well as moving forward along the ground. Thus, the ball undergoes a rectilinear motion as well as rotational motion. Can you think of other examples where objects undergo combinations of different types of motion? We did many measurement activities and discussed some kinds of motion. We saw that motion is a change in the position of an object with time. The change in this position can be determined through distance measurements. This allows us to know how fast or slow a motion is. The movement of a snail on the ground, a butterfly flitting from flower to flower, a river flowing, an aeroplane flying, moon going around the earth, and blood flowing inside our bodies show that there is motion everywhere around us. Keywords: circular motion, distance, measurement, motion, periodic motion, rectilinear motion, SI units, units of measurement. Summary. Different modes of transport are used to go from one place to another. In ancient times, people used length of a foot, the width of a finger, the distance of a step as units of measurement. This caused confusion and a need to develop a uniform system of measurement arose. Now we use International System of Units, that is SI units. This is accepted all over the world. Meter is the unit of length in SI unit. Page 106. Motion in a straight line is called rectilinear motion. In circular motion, an object moves such that its distance from a fixed point remains the same. Motion that repeats itself after some period of time is called periodic motion. Exercises. 1. Give 2 examples each of modes of transport used on land, water, and air. 2. Fill in the blanks. 1. 1 meter is blank centimeter. 2. 5 kilometer is blank meter. 3. Motion of a child on a swing is blank. 4. Motion of the needle of a sewing machine is blank. 5. Motion of wheel of a bicycle is blank. 3. Why can a pace or a footstep not be used as a standard unit of length? Four. Arrange the following lengths in their increasing magnitude. 1 meter, 1 centimeter, 1 kilometer, 1 millimeter. 5. The height of a person is 1.65 meter. Express it into centimeter and millimeter. 6. The distance between Radha's home and her school is 3,250 meters. Express this distance into kilometer. 7. While measuring the length of a knitting needle, the reading of the scale at one end is 3 centimeter and at the other end is 33.1 centimeter. What is the length of the needle? 8. Write the similarities and differences between the motion of a bicycle and ceiling fan that has been switched on. Nine. Why would you not like to use a measuring tape made of an elastic material like rubber to measure distance? What would be some of the problems you would meet in telling someone about a distance you measured with such a tape? Ten. Give 2 examples of periodic motion. Suggested projects and activities. 1. Draw a map of your classroom. Roll a ball on the floor. In your map, mark the points where the ball started and where it stopped. Show also the path it moved along. Did the ball move along a straight line? 2. Using string and a scale, let each student measure the length of his or her foot. Prepare a bar graph of the foot length measurements that have been obtained for the whole class.